Hello grade 12, welcome to my channel, and let us have a look at some trigonometric identity questions and perhaps questions related to that. Of course, I got this, compilation of past exam question papers from one of my students when we were doing some classes on certain topics, trigonometric functions to be specific. And you can see this came from the WTS Academy, which is based in KZN. So you can find them in Durban, Richards Bay, and what is this place? I mean, even areas like Newcastle. Oh, Bosch, Matadin, Anvil, and Dendek. Yeah. That's where my mother comes from. Anyway, let's have a look at some trigonometry identity related questions and see how we go about business. All right, so we're going to start with this question 5. And just do our business. Of course, guys, my table makes a lot of noise, so if you pick it up, please forgive me. I sit better on this table than elsewhere. All right, so we're going to just do all these question 5s because they are more like identities. When we have to prove something, it's typical of an identity. So we have 10 of 480 degrees times sine 300 degrees times cos of 14 degrees times sine of minus 135 degrees. All of that divided by sine of 104 degrees times cos of 225 degrees. We are told that this should be 3/2. Okay, that's typically an identity. Okay, so what are we going to do? Left hand side is a lot more complex. And then, of course, you copy this again into this space over here. Of course, I have, the luxury of doing that. You do not. Now, folks, we see that we've got big angles. Anything that is not an acute angle needs to go. Okay? So, first, the 3-step approach, as we know, BODMAS, right? Let's go for it. 3-step approach. Okay, so we know that step 1 is BODMAS. So now I'm not going to explain how we use it. Sorry, step 2, we factorize. Again, I'm going to leave you to decide. Step 3, it can be an identity since we're doing trigonometry, but laws of maths, exponents, theorems, rules, you name them, cosine rules, etc. Anything can be used here. So here we're going to use our BODMAS. We need to deal with reductions. So this is 10 of 360 degrees plus. Let's see what's 480. 480 minus 360. That's 360 plus 120 degrees. Okay. Times sine 300 is 360 degrees minus 60. Cos 14, since it's an acute angle, we leave it alone. Now this one is a bit naughty. This is going to be minus sine. Now 135 is 180 degrees minus 45 degrees. Okay, we're moving quick. We don't have time. So once you're comfortable with these things, folks, you will see it becomes a lot easier. 104, I just want to use this 14 because it looks related. So this is going to be sine 90 degrees plus 14 degrees. Looks all right. Times cos of 180 degrees plus 225 is 180 plus 45, right? Nice and easy. Now we start reducing. Now we know tan of 360 plus is literally an angle in the first quadrant in principle. We forget about that being 120. It will correct itself. So this is going to be plus tan 120 degrees times sine, this is going to be minus sine 60 degrees into cos 14 degrees into, now this is 180 minus, it would be positive but it's dragging a negative, so this is minus sine 45 degrees all over. Now sine changes to cos 14 degrees into minus cos 45 degrees. Cos is negative in the third quadrant. This is equal to, now we can reduce this, but now we know this is 180 minus 60, but I'm going to just ditch that part for now. So we have, what I'm going to do, I will just copy this. Of course, for you guys, there's a lot of writing. For me, is to use the technology. Doing technical things. All right, so let's sort this out. 120. 10 120 is as good as minus 10 60 degrees, isn't it? Yes, that is easy. It's in the second quadrant. It's 180 minus. I'm just prolonging the inevitable. So what do we see here? This is minus square root 3, right? Right. Minus sine 60 is a root 3 over 2 times cos 14. We leave it as it is. In fact, this one doesn't even need to come through because this and that divide to 1 and literally become invisible. So sine 60, this is minus, no, this is minus sine 45. This is 1 over square root 2. Okay, all divided by, here again we're going to have minus 1 over square root 2. All right, so again, this whole bracket is going to take that bracket and everything is gone. So let's see, root 3 times minus root 3 is just 3 over, then 2 times 1 divided by 1 is just 2. So indeed, here we don't necessarily need to say the right hand side is equal to the left hand side, because this is too simple. It would be very challenging to complicate it. So let's just leave it at that. So how many marks do we score here? 6. Okay. So obviously these reductions, folks. 1, 2, 3, 4, 5. Okay, and then the use of special angles here, 6. This was already volunteered, so everything else is the problem for you, not those who examined you. All right, so let's look at 5.1.2. We are given cos of 75 degrees is equal to the square root of 2 into root 3 minus 1, all divided by 4. Okay, now we will take the left hand side. It's much easier to deal with this. What is it? Cos 75 degrees. This is equal to, now we know that it would have been tough to change this into that, although we can, but with lots of difficulty. But now let's try to get 75. Let's see, what is it? This is not a special angle, but we can use special angles to create it. 45 plus 30 is 75, so this is the same as cos 45 plus 30 degrees. These should have been clues that there is special angles involved. So usually when we inspect, we would know that it's giving us the vibes. Okay, now we've got an identity here using step 3. So this is going to be cos of the first angle times cos of the second angle. The sign changes. Take sine of the first angle times sine of the second angle. Okay, this is equal to, now cos 45 is 1 over square root 2. Okay, multiplied by cos 30 is root 3 over 2 minus sine 45 is 1 over square root 2. Sine 30 is a half. Okay, so we deal with these, we multiply. Remember, brackets come first using BODMAS. So we have root 3 over 2 root 2 minus 1 over 2 root 2. Alright, so we've got a common denominator here of 2 root 2. Then we just simply add the numerators. Great. But now what we see is that our answer is not exactly the way we want it. So we can see that there's no square root on the denominator. So we rationalized. So here we will multiply by the radical we're trying to get rid of. Alright, so if we do that, what do we end up with? We end up with square root 2 into root 3 minus 1 divided by, now this becomes 2 times 2, which is 4. And indeed, that is good. So, not a very difficult question. If you just remember, this thing is very helpful. It is directive. You don't end up where you don't need to go, usually, if you use this technique. So obviously, folks, this using of special angles to create the compound angle and using identities is very good. Using special angles is very good. And rationalizing is the 4th mark. So very easy, not too complicated. So I hope you guys would see how easy that is. Okay, let's look at 5.2. We need to prove that. Okay, so let's write it out first. Cos of 90 degrees minus 2x times the tangent of 180 degrees plus x plus sine of 360 degrees minus x should be equal to 3 sine squared x. Okay, now this is an identity. We'll take the complicated side. Remember, in the exam, no time for silly gymnastics there, although you can do them if you feel you have enough time to showcase your talent. Now, we know that when we reduce this, we use cofunctions, BODMAS, right? So this reduces to sine 2x. Okay, into 10 of 180 plus x is just as good as 10x. That's the third quadrant. And then this is going to be plus sine of 360 minus is minus sine x. Okay, good. We come back, we can use identities now. This is 2 sine x cos x. We can say this is over 1 multiplied by tan is sine x divided by the cosine of x minus oh my lord, this is squared. Goodness, wrong expression. So this is squared, so it becomes sine x sine squared x over 1. Since we have fractions, we try to balance the equation right there. So this and that divide to 1, and the numerators multiply, so we end up with just 2 sine squared x over 1 is just itself plus sine squared x. This gives us 3 sine squared x, which is equal to the right hand side, because this we can take back. Usually it's not too simple. So essentially the identity has been proven. We're scoring how many marks? 6 marks. Wow. Okay, this reduction is good, that reduction, and perhaps we can say this reduction. This is 3 marks. And then when we use identities, that's the 4th, that's the 5th mark. And maybe using this one, solving the bracket is good. These are like terms, they add up nicely. Not a big deal, but I think the last mark is good here. So we have our 6 marks, not too difficult, very easy to approach. Okay, let's have a look. Question 6, do we have anything? If we're proving something, it looks like an identity. We can take that 6.1. Let's just try 6.1. 6.1.1. Perhaps let's just move it up to save some space. So what do we have? You've got 10x minus 1 into sine 2x minus 2 cos squared x is equal to 2 into 1 minus 2 sine x cos x. Okay, so obviously we've got brackets, we've got terms, but what makes it more attractive to start on the left hand side is that double angle over there. So we will take our left hand side. Of course, I've got the luxury now to just save a bit of time so that we don't stay too long here. Now there it is. this is equal to, now remember, BODMAS will dictate that we handle brackets first, so don't be too overzealous and start using identities. So if you FOIL this thing out, we're going to have sine 2x times 10x minus 2 cos squared x times 10x minus sine 2x plus 2 cos squared x. Okay, so that's just FOIL method. Now once this is done, what did we allow ourselves to get into? Identities. So this is 2 sine x cos x. Since we're going to get a fraction for the 10, we may as well get ready. So this is sine x over cos x minus 2 cos squared x. We can say this is over 1 times sine x over cos x minus, it looks like we will need some space now. Let's just move everything back a bit. Let's back it up. All right, so this is minus, okay, let's leave this one, 2 sine, let's just say minus sine x minus sine 2x over 1 okay, since everything looks like we have fractions, so we know that this will divide that to 1 and literally disappear. This will take the square, and that's it. So we just deal with the business. This is equal to 2 sine squared x. That divided by 1 is just itself, minus, this is 2 sine x cos x. I'm just rearranging so that it looks like an identity, minus, and this is 2 sine, we're using identities also here, right, and then plus 2 cos squared x. All right, okay, all right. Now we can see that these guys are like terms. Cos squared x, sine squared x, so we can group them nicely. So this is 2 sine squared x plus 2 cos squared x. Okay, minus. Now these ones are also the same, like terms. So this is going to be minus 4 sine minus 4 sine x cos x. Right? Right. And then we factorize here. We get 2 into sine squared x plus cos squared x minus, why didn't I just factorize here? You know, it would have been very nice, you know. Yeah, but since we have 2 sine x, we can just pull out a minus 2 here. And then we're going to remain with 2 sine x cos x. It's not a big deal. We take out a 2 just to simplify this further. Now, we can appreciate that this is just 2 into 1 using our identities, minus 2 into 2 sine x cos x. Then we take out 2 as the highest common factor. We end up with 1 minus 2 sine x cos x. So in this identity, we've literally used all the 3 steps in a way. Okay, that was a bit hectic. Of course, guys, this one, if you don't strategize when it is this long, you will suffer, because you will start doing things that are going to go against you. So don't allow it. Okay, so let's see. Where do we score the marks? Well, FOIL method is not a big deal, literally, but identities right here, those are marks. Okay, if we used the 10 identity, could we get another mark here? How many marks are we scoring? 5. Okay, let's rather delay this one here, because we used 10 twice, so I think it's fine. Then from there, we used an identity here. Okay, maybe we should mark it. So this is 1, 2, 3, 4, right? Yeah. And then grouping here and using the identity that this is equal to 1, that's the 5th mark, because the rest is just simple factorization. Of course, factorization gives marks sometimes, so one may want to retract that 10 identity there and perhaps come here and say, for the factorization here or here, there's just too many areas, folks. So yeah, I don't know what to do. But yeah, this is what it is. This is what it is. Let's just leave it at that. Sometimes the examiners will decide where the marks are. Okay, guys, so this WTS Academy, there is their number. Please talk to them if you need their help, especially if you are in places like Richards Bay, Durban, Newcastle, you name all the KZN towns, okay? Mostly they are the Ladysmith and stuff. So that you can get in contact classes through them or any other form of assistance you may require. Okay, so let's take this question. Okay, here we don't have identities, we just move. Just keep looking for what looks like an identity so that we can deal with it. So we're going to take 9.2. It looks like an identity, or at least we can consider it an identity. Question 9, we're doing 9.2. Okay, so we need to prove. Once we prove, remember, it's an identity, okay? Especially when it's an equation on the left-hand side and the right-hand side. So we've got sine of 190 degrees times cos 225 degrees times the tangent of 390 degrees, all divided by cos of 100 degrees times sine 135 degrees. This should be equal to 1, minus 1 over the square root of 3. Obviously, this is telling us that we will need special angles, because that root 3, we know it comes from those dudes. Now sine, we set it up. 190 is 180 degrees plus 10 degrees, right? Because we can see there's 100 here. it should be 90 plus 10 as well. So we're going to use cofunctions there. So we can sometimes see it from the word go. 225 is 180 plus 45 times 10. What is this? 390 is 360 degrees plus 30 degrees. Nice and easy. All this is divided by cos of 90 is, sorry, it's cos of 90 degrees plus 10 degrees because we want to get that out, times sine 180 degrees minus 45 degrees. In fact, this step is too fast. Be as systematic as possible. We still need to take the left hand side and, you know, say it. We must say it. The left hand side is giving us that, which then leads us here. Okay, so we reduce. So this is minus sine 10 degrees times minus cos 45 degrees. This is not looking right. It just doesn't look right. Into now 360 plus in principle first quadrant 10 30 degrees, all divided by this changes to minus sine 10 degrees. Remember, cos is negative in the second quadrant, so well, its co-ratio. Here, sine is positive in the second quadrant. All right, so remember, guys, we cannot see you come from this step. This is a forbidden path. You cannot do this. This is not allowed. Please don't do it because the instruction is clear. The instruction is very clear. We need to show through this step. We may not get marks, but we need to show. Okay, let's keep going. What is this? Since this whole thing is a product, this bracket will divide that to 1 and it's gone. So we're left with minus 45 is minus 1 over square root 3. Sorry, no, square root 2. Okay, then 10 of 30 is 1 over root 3, isn't it? Let me think again. Don't think I remember this well. So if we've got 90, this is 30 degrees, this is 60 degrees, adjacent to 30 is root 3, opposite is 1, that is 2. Now 10 of 30 is, yes, 1 over root 3. Okay, good. Sometimes you forget, you just need a bit of a reminder. This is divided by 1 over root 2. Now this will divide that and leave a minus 1. So this is going to be equal to minus 1 over square root 3. This one we don't need to say left hand side equals the right hand side because we will struggle to try and reverse this into that. Okay, so sometimes look at the expression and see what you can do, see where your limitations are. Of course, this reduction, that reduction, that reduction, this reduction, and that reduction. So you can see here we've got 1, 2, 3, 1, 2, 3, 4, 5 marks. Using special angles, 6 marks. So where is the other mark? I don't know, because we are given 7 marks. So perhaps the answer, although it was volunteered, it's not a big deal. Okay, so you can see, guys, these things are very easy. Not a problem at all. Not a problem at all. Okay, all right, okay. So we've got some more identities on question 10, which we need to look at. Of course, guys, we're going to do as many as we can. I'll try to use an hour at least to 2, so that you can get the hang of it. Now it says, using the expression for sine a plus b and cos a plus b, prove the identity of that this situation. Of course, this is the 10 compound angle identity, which I have shown you. Can you see, guys, even though it's not necessarily commonly examined like this, you just have to do it. You just have to do it, okay? So that when a question like this comes, you don't struggle. So 10.1, we know that we are told to deal with sine of a plus b divided by cos of a plus b. We need to show that this is going to be tan of a plus tan of b divided by 1 minus tan A, tan B. And in fact, I saw you guys ignored the video that I did on the 10 compound angle identity, and you think you can escape it. These could be easy marks if you pay attention. Of course, we want to take the left hand side because we are already told what to do. Can you see we are told to use these expressions? So we cannot find ourselves coming to the right hand side and reducing it to the left hand side. So we need to choose the left hand side. For you, more writing. For me, less. Using the technology. We're using the technology. Now let's see. This is equal to. Now the expansion here using identities is going to be sine of the first angle times cos of the second angle. The sign remains. It's cos of the first angle times the sine of the second angle, all divided by cos of the first angle times cos of the second angle. Sign changes, sine of the first angle, sine of the second angle. Okay, so now we know what we're trying to do. All right, okay, all right. So now what do we do, folks? What are we going to do? Well, I've shown you what to do now. So we just want this to go to 1 because we already know the sign. So sometimes you look at what you're trying to achieve. And now we can see that, okay, to get 1, it is nice to just divide by this dude. Divide itself. And so we can get what we want. Okay, so that's the strategy. So always, guys, whenever something looks strange and it's not directly linked to what you want, look at what you have and see how you can get yourself into it. Of course, guys, in maths, we can multiply by 1. Because 1 is a multiplicative identity. So there's a lot of tricks that need to come in here. Of course, I don't know if there's another way that people can do this, but sometimes knowing what to do is very important. But remember, if we want to divide by 1 here, so this we will write again that we will essentially multiply this by 1 over, we multiply by 1 over cos A times cos B, all divided by itself. Remember now we're creating a very complex type of 1 because we want to handle the numerator and the denominator the same way. Some people may easily say, if we divide by this in the denominator, we must divide by this in the numerator as well. So it depends on how you want to look at it. But just logically, when we multiply by 1, this is what we are doing. Remember, the numerator divided by the denominator is just 1. And we're just going to multiply this into, perhaps let's just do this. Is it necessary to do this? We can do 1 lengthy. Come on, man, curve. Doch, going to give me a headache. So this is sine A cos B plus cos A sine B, all divided by cos A cos B minus sine A, I don't know what that is, sine A sine B. All right, so this is what we have, guys. And guess what? The numerator will multiply into the numerator. The denominator will multiply into the denominator. So we end up with, if we multiply there, we get sine A cos B over, the denominator is going to be cos A cos B, plus this multiplied by that term, it's going to be cos A sine B, divided by this cos A cos B. Now all of that is divided by, again we do that, this multiplied by the first term, it's just going to be cos A cos B divided by cos A cos B, minus that multiplied by the next term is going to be sine A sine B divided by cos A cos B. Nice and easy. So now the magics happen, right? Right, what do we know? Sine A over cos A is an identity for tan. Cos B divides cos B to 1, and it literally disappears. And then we have sine B over cos B. That's a tan identity, while cos A will divide cos A to 1 and disappear. So what do we have now? So sine A over cos A is tan A, plus sine B over cos B is tan B. The major division there. So we know that the numerator divides the denominator to just 1. Again, we've got a date here. Sine A over cos A is an identity, as well as sine B over cos B is an identity. So this is 1 minus, this becomes tan A times tan B. This is equal to the right hand side. Okay, so again, three-step approach. You can see 3 marks here. It looks too simple, but you can see there's quite a bit of writing that needed to happen there. So how do we score the marks? Of course, guys, we can give a mark for the expansions, but since we were directed, I wonder if we're going to get marks, because we were told what to do here. So I feel like that is not good enough, but I think the multiplying with 1 here is what matters. That's the first mark. And then after we have done what we've done, using the identity there, it's a mark. So for the numerator, we get this mark over here. Right? Okay, that's too much. That's too much. So we can 1 mark for the numerator and 1 mark for the denominator. Yikes, this looks crazy now. Anyway, that was just 3 marks. I would suppose mark for the numerator, mark for the denominator, although it was already given, but since we had to use identities to get these, it sounds right to do that. Okay, so not very complicated, but certainly something that is, crazy. Let's look at this 10.2. If 10a plus b is equal to sine a cos b, prove in any triangle ABC that 10a times 10b times 10c is equal to 10a plus 10b. Wow. What a wow. This is a very good question, I suppose. I think it's worth looking at. Okay. So utusazihlalele kamnandi. Usarelaxile ne-questions ezi-approachable. Vele kufika i-question ephambene njengane. You're like, what the hell now? Have you ever seen anything like this? Well, this is why we need to know our 3-step approach. Enormous. Where is it? Sangapa. Out is migrating. We need you. Let's go down. How lazy is a man? Yeah, this thing is moving slowly. Come on. Eh. Do it. Okay. You're too big. All right. So this is what we have technically. All right. Now, this looks crazy, isn't it? But remember, we know what we know. This part, we can make it the subject of the formula. I suppose. And we then multiply it with 10c. And then see what happens when that happens. All right. Because we will just take this identity as it is, right? Right. We take the right-hand side, and then we just isolate this dude. Once we isolate this dude, we just simply multiply this by 10c, because I don't see any better way of approaching that. So this is the odd one out, but remember in maths we can multiply by anything. And let's see if this anything is going to give us what we want. Of course, I might just run myself into a problem. That is possible. It's not a problem too much, in that we know that the sum of angles of a triangle are literally what you call supplementary. And so this means this angle C can be represented by 180 degrees minus the sum of A plus B. So we need to think about these things, folks, as we plan our way forward, because we don't know if we're going to win. Of course, it's just 4 marks because the examiners know what you know, that you may struggle to see this. But if you are one of the persons who like to reverse things and play around things like I always show you, you will succeed. Okay, let's see. Actually, guys, I'm hungry. My food is gonna get cold. Let's quickly finish this question so that I can eat. And then we do our thing. Okay, maybe let's say 2 hours of this, perhaps. Just to do as many questions as we can. But technically, guys, this is called spoon feeding now. This is bad. If you are a mathematician, to be or wanna be, and you need spoon feeding to get around maths, you fail at university, guys. Please be aware of that. Remember, you need to assume independence. Please do that. At this stage, I need you guys to get to the level where you practice everything using all the approaches, the tricks, the logic. Sometimes you include your talent in there, your creativity, your flexibility. You read, you study, you research, check on the internet, check some websites where you can study certain concepts further so that your brain is much more wide in approach. Once you have a lot to choose from, you start to choose well, okay? Because when you're faced with a lot, at first you become overwhelmed. But as you keep going, you start to know how to pick your battles. Then the moment you know how to select the right choices, this is when you start to win often. Okay? Not always, but often. All right. Anyway, anyhow, so what are we going to say, folks? We know and understand that, number one, we will take that identity as we have found it or as we have seen it. But what I'm going to do about it, okay, let's not worry about what we're going to do about it. So what I'm going to say is, we know that sine of A plus B over cos of A plus B gave us 10A plus 10B over 1 minus 10A 10B. We proved it above, so there's no issues around it. But now this implies what? Remember, we saw that this is 10A and B, so we first simplify this one. This is equal to, this means 10 of A plus B is equal to 10 of A plus 10B over 1 minus 10A 10B. I smell trouble though, but it's not a big deal. So this is all over 1. So what do? We cross multiply. You get it? Yay! We can do it. We can do it because we want to isolate this dude. So this implies that 10 of A plus B, I'm not sure if this is well or this is not, but it's not a big deal, into 1 minus 10a 10b must to can be equal to what language is that? Yeah, is ornamos. It must to can be equal to so this is 10a 10b. You know what? I'm feeling like I've got a bed here. So you go pop. So you go pop. Seyikhona indawana ephaphayo apha kum uyayibona. So there you go pop. Actually this thing times 1 is itself. Okay, so we have a portion of what we want, folks, and we've got a portion of what we want. Now what is left is this issue of 10c business, which we don't know what we're going to do about it, but I'm trying to see if, you know, must things work out or they don't. Yikes, it looks like we have a problem though. We do have a serious issue. But hey, let's just keep going. Let's just keep going. Part of me is wanting to say certain things that I'm not supposed to say. Okay, let's just divide by 10. Let's divide by 10, a plus b. So we've got 1 minus 10a times 10b is equal to 10a plus 10b. Now my problem here is this 10 of a plus b. Although we understand and appreciate that the things that are doing what we are doing, this 10a plus b is going to have to be eliminated by our friend, I suppose. It feels like heat. So yeah, sometimes ufunulila kodwa ungalili msinya ne. Don't cry just yet. Just wait a bit, okay? So folks, we can appreciate that we easily can transpose this dude to the other side. And then we transpose this dude to the other side and rearrange. So this implies that literally 10a times 10b is equal to, we move this over, so this is 1 minus 10a minus 10b. Okay, the signs are a little bit crazy-ish, but it's not a big deal. You get it? You get it? Yeah. Okay, maybe I'm too overzealous at this stage, so let's leave this one like so. Aye wena man, what is this man? Ke njwala ntweni iskatlontina jwala iskatlontina ha ke diphahlo nna hobaneng e batla ho ntina jwala. Aye, skatlonkeetsa jwalo ha ke etse wintho tseno nna ke kwatse hampe e seng hantle hampe haholo. So skantena re tlo qabana wankwa. Now folks, remember what we can do here, we can just multiply by 10c mos, because we can multiply by anything we want. We saw that there's a 10c. I don't know how to bring it, so I'm gonna do it the mechanistic way. Times 10c. So this is going to be 10a times 10b times 10c. Yes. Why? But why, man? Why are you doing these things? I am doing these things because these things are just the things. So we're going to have 10c into 1 minus 10a times 10b over 10a plus b. Okay, now this qualifies as the big bracket or the square bracket, if you call it that. Okay, so guys, we can multiply by anything. Of course, I don't know if this is good, but sometimes in maths, when shit happens, you just deal with it. Okay. You cannot cry. Now, le nyama bafowethu ngilambile. Kayiwanyana nje, yabo. Kayiwanyana. Okay, let's not waste time, but yeah. Now, sorry guys for this. This is unprofessional. No one should eat while they teach, okay? It's bad. But I couldn't resist a bite. Ngalamanzi abanda kamnandi. So ndifumene nje sendinxaniwe eqona. 10a 10b times 10c is equal to, now we FOIL this thing out. This is 10c minus 10a plus 10b all over. Be careful here. I could have used brackets, but I'm not interested, okay? So this is over 10a plus b times 10c. Okay. Injalo nje. Ifuna ukuba njalo. Maske sithi ukudrifta kancinci. Let us just drift back a bit. Let's back it up. Back it up. Yere toch. I think it's a nice challenge, see. But usazihlalele kamnandi vele kufika into ezoqedela injabulo nje seziyiqedile. Hayi, kodwa ke thina akasithengisi ngenjabulo yethu. If you didn't catch that, you just sit there enjoying trigonometry, doing nice things, and then a nasty question like this comes and just finishes your joy. But we don't sell our joy. Our joy is better than happiness, you see. It's like climate. You see, joy is climate. It's over a long period of time. While, happiness is like, an episodic thing. It's a weather-like thing. It's like cold in the morning, and then it's nice and warm in the afternoon, and then it goes cold again, or it rains in the afternoon or at night or whatever. But you see, it's not... It's what is it? The longevity, or is it the longevity? Longevity of it is just terrible. So we prefer the weather, the climate. We don't deal with the weather here. We deal with the climate. Now we're like, friend, you look strange, Moss. We need to get rid of you, man. There must be a way of dealing with you. You hear? Yeah. We need to get rid of you. But how do we do it? Well, we need to think and think very hard. We need to think and think very hard. Yeah, folks, I don't know how we're going to do this, but for 4 marks, guys, are you kidding me, man? You're kidding me. Okay, so we can say, however, in triangle ABC, we know and appreciate that, but I'm not quite happy here. Okay, but we're going to be strategic. For us to get rid of this, we're going to have to manipulate this 10C because we want it gone. Because we already have our 10C there. In this triangle ABC, we understand it is such that angle C is equal to 180 degrees minus the sum of angle A plus angle B. All right. Okay, maybe we don't need the cap here. Okay. Why? This is from the sum of 3 angles of a triangle. Do you see these things? You see, you're doing trigonometry, but now you find yourself with some Euclidean geometry things. So what are we trying to suggest? We are trying to suggest that angle C there, but here we're going to strategically, if not strategically, we're going to target that one because we want this one to remain. So this then follows that 10A times 10B times 10C must to can be equal to hey, the English you will hear, boys and girls, ladies and gentlemen, is amazing. Ekambeni kwami kulo mhlaba ndive ilwimi lesingesi or lesilungu lithethwa ngenye indlela engayiqondiyo. 10 A plus B times. Now, what are we going to say? We're going to say tan C is tan this angle here. Okay, I'm forced to drift, guys. As much as I hate to drift, I just have to, so that my things can flow. You see, maths must flow, guys. It's a language, this thing. It's like writing an essay. If things don't flow, you will die. Okay, 180 degrees minus A plus B. Hayibahle inqala ham visual. Riri hatamelise mona hatamela man. Hatamela skachechela kwano mpale yang ubani umpale. Ke jabatho nna jwale umpale skatlontina wena. Ay, skatlontina wena man. Wabona hejwal. Tlokabana. Wantella biano. Yano wantella. Hana bari wantelela. Habacho hore wantella. Bari wantelela. Hey, when safundi isilungu. Okay, so do you see? We're not going to substitute that because we already want 10C. So 10C ukhona simiyeke njalo, but we deal with this one because we want to get rid of that denominator. So this implies that 10 of A times 10 of B times 10C. Okay, we're going to leave this 10C for now. So this is going to be minus 10. You know what I'm thinking? This negative must come out. because it's going to cause us problems. Let's just do this so that we can avoid issues, because it will lead us into some serious mayhem. So let's put some big brackets, some small brackets around this to avoid issues. You get it? Yes. Because the sign here is going to be a horrible situation if we don't do it. Okay, so this is the bracket of 10a, 10b over 10a plus b times. Now we reduction formulae, right? 10 of 180 minus, that's the second quadrant. This becomes minus 10 of a plus b. All over 1. Now see the matrix, my friends. This one takes care of that one. Now we just multiply these things. So we'll say therefore 10a times 10b times 10c is equal to negative times negative is positive. 1 times this thing is just that thing. So we can write it nicely now. 10a plus 10b plus 10c. Sigqibil. All right, so this one needed us to work with both left and the right hand side, because if we chose one side, we were going to run into some serious problems. You understand me, my friends? It is like that. It is like that. And we don't want that. You understand me? So folks, yep, I don't know why this thing is 4 marks, but perhaps the examiner is trying to save you from yourself, because you would definitely have some issues here. You would run into serious problems. Let me just get my tablet charged, because if I don't do it, it's going to cut me short. But of course, guys, I don't want to do too many questions, because I think the basic questions, the 3-step approach is quite directive. You would find your way nicely. So essentially, folks, this is it. I don't know where the 4 marks are, actually. I really don't know. I honestly do not and will not know. All right, okay, all right. Now, let's have a look. What did we do? We used an identity here. All right, right. Now, making something the subject of the formula is not really that interesting, okay? But I think what is interesting is this step. When we multiply by 10c, we can say this whole shenanigan is perhaps the second mark, okay? And now, what is also very interesting here is this story right here, folks. That story needed to come out. So don't think Euclidean geometry is going to escape you when you're doing trigonometry. No. Okay, let's not get too excited. Actually, I'm excited because we got the answer. Otherwise, I was like, yabona what class strategy. I said theorem. Is it a theorem, this one? Is a theorem, or it's a law, it's a rule? You see, 3-step approach. Hi guys, if I appreciate Lendo. I have a hale rat in twin. I get able to rata in 1 in 20 years. I do live fail. I finally the politicians. It's a South Africa, but one very episode into thing madam. Empa how lily one. Young fail. Hi. The agent to tell the cletty gimpa. Tell you hollow mona. Yama furade. Empa. Renteri la pile mona. Hanakas casituana he holapa. Give me that. Why born? Yeah, go on to you. Which hore hair, Banabis. Haeba ha le rate 3-step approach ya ka mona. Ke tseba re le tlo rata eng hobaneng yona ya le rata. E le etsetsa mosebetsi wa lona o be bonolo. Empa haeba le rata mathata. Ke kgetho ya lona nna ke le bontshitse hore ntho ena ya sebetsa. Haeba lona ha le rate kampa ha le bone hore ya sebetsa, le tlo ipona. Ke tsebang ke hore fela le tlo kopana le tosa le madinyane wa yona haeba ha le etse ntho e ntle kampa ntho e sebetsang. Wa nkutlwa jwale he mannyeo. He man. Nshebe. Ke bua le wena hantle no nshebileng hona tjena. Anyway, guys, this is just crazy now. Anyway, I can't get over the excitement of knowing how to solve this thing after so many years. Goodness, my gymnastics are still there. Now you need to acquire some mathematical gymnastics, because remember, this thing is like in the circus or something. You're going to be doing crazy things. So you got to enjoy and appreciate. Now, folks, when we're doing a reduction formulae, that's the extra mark. Sometimes substitutio is neither problem. We are not really that much interested, if not interested. Anyway, guys, these 4 marks you can see, the examiners were just being mean here. But at the same time, they were being friendly, because you know what? Sometimes these 4 marks could really horrify you. And you would not know what to do. So in maths, guys, you need to be strategic. You need to really understand what you're doing. So these are very good questions. I can imagine this question must have come from some old question paper, because I know you guys would not handle this. I can tell you without even a doubt. Of course, there are some of you who are just very good. In any case, he's all right. He's okay. He's all right. Now, let's take this one. I think this should be the last one, guys, so that we can avoid overly doing. I mean, there's plenty of questions here. There's truly a lot, but we can't do everything, hey? We just can't. At some point, a student has to practice for themselves. Okay? All right, okay. So maybe let's just take this. Let's take this 10.3, because I like this part. This is what is actually attracting me into this question. You know, when there's some strange things being said, this is when I get very excited, because you know what? We're not doing general solutions here. We just want to prove identities. So maybe let's take this as our next question. Then you guys are going to do the rest, okay? So let's take these 3 identities and stop. Of course, we can't spoon feed you. You need to learn by yourself. So this is now question 10 again, from wherever. Now, question 10.5. Now we're going to do 10.5.2. So can you see, guys, I'm numbering the questions I'm answering just the way they are labeled. So learn this art so that you don't run into problems. Okay? All right, okay. So we have cos 2x times 10x over sine squared x. This is to be equal to cos x over sine x minus 10x. Okay, fine. This says for all other values of x. Hey, yeah, sometimes the things that get said is interesting, is it not? Definitely. Okay, all right, okay. Now let's look at this thing. Left hand side, this is cos 2x times 10x all over sine squared x. The reason I'm choosing this is because of the double angle. Okay, great. So we can see that we still have cos and sine, and then we've got 10. So what is the issue here? It is very easy. This is equal to, now how are we going to handle this business right here? Well, we can handle it in two ways. The one thing I want is to eliminate one cos here because I only have one left. So I just want to get rid of perhaps one cos and see what happens, because you see I've got a sine squared and then here I only have a sine. So this means it is safe for me to say this is 2 cos squared x minus 1 using the identity there, into 10 is sine x. Okay, let's do it this way. Times, we have, goodness, sine x over cos x. So there you are. Ke wena motho. One pawn. Yeah, don't shebile wena. Since we have fractions here, let's just say this is over 1. So that this looks nice instead of looking gray, a little bit bad. But part of me feels like, we want to do things, but let's not rush into doing things. Doing things is sometimes costly. We distribute here. So we're going to have 2 cos squared x times sine x over cos x minus sine x over cos x. This is a flip-flop, moss. Yo. It's a flip-flop, this one. Yeah, these questions, the examiners were at war with the students here. I see it. We're doing a flip-flop. This one takes the square. Nice and easy. And then, what is next? Yeah, doch, it is what it is, okay? Yeah, but it's driving us home, folks, not to worry. So this is now 2 cos x sine x. And now all of that is divided by this denominator, just sine squared x. Hey. This is sine x over cos x. This one also divided by sine squared x over 1. Remember, each term on the numerator is divided by this. I'm feeling like there's a crime somewhere because I have a 2. I don't know what I'm going to do about. How did I end up with the 2? Did I do the right things? Think so. Anyway, guys, this takes that. Okay. So it looks like we're going somewhere, Moss. We're going somewhere, Moss. Yeah. So we have 2 cos x over sine x minus sine x over cos x times 1 over sine squared x, and that sine x takes the square. Hayi, angisazi ke manje, sekwenzeke ezinye izinto engingazazi manje. This is 2 cos x over sine x minus 1 over cos x sine x. Hey, how many marks was this? 5. Yawena. Theni ngathi ufuna ukunilinga nje. My 3-step approach is in my head, but I feel like I'm not getting where I want to go. Why am I not getting where I want to go, Moss? Okay, let's make this one the common denominator. So the common denominator is cos x sine x. Hi guys, ngeke. Khani into endingayithandi. You know, I don't like something, but it looks like it's coming out nicely though, because when we take this and divide that, sine goes, and then we've got, yeah, this one, I call, hey, Hey, let's leave it. So this one is gonna be 2 cos squared x. This question is starting to irritate me now. Minus 1. Hey. Yeah, this one is flip-flopping, Moss. This one is flip-flopping. I am not exactly pleased. I am not exactly pleased. Yeah, maybe there's a mistake I did, because isikwenza kube nzima lokho manje. Akuyathaba jwale. But let's convert this one. Let's convert this one. This is 2 into 1 minus sine squared x, using square identities minus 1, you know. Sometimes you gotta be a little bit creative. Cos x sine x, because sometimes you may think it's wrong what you're doing, but it's actually right. It's actually right. So we have 2 minus 2 sine squared x minus 1 all over 2 cos x sine x. I feel like something is gonna give the 2 minus 1. We've got 1. 2 minus 1 is 1. Minus 2 sine squared x all over cos x sine x. Hi. Aibo guys, kwenzakalani? This is 1 over cos x sine x. I'm not quite happy with this question. 2 sine squared x over cos x sine x. Damn it. This thing is not good, man. Yo, kanti ke kwenzeka ntoni apha? I feel like this is not supposed to be solved like the way I am solving it. Whew. I think our strategy is failing somewhere. Okay, guys, this is not getting us anywhere, and I'm feeling like, no, man, something is wrong. Okay, it happens. See, now my judgment is also going astray, so let's just back up a bit. I don't even want to study this whole thing. It's already horrible. But not studying it is a crime, because I may find myself doing the same thing over again. Okay, let's just back it up a bit. Let's back it up. Okay, so we said this is cos 2x over, okay, we did what we did. Now, oh Lord, perhaps the expansion is not right, because we need to have cos over sine, which is fine. We saw something like it anyway coming up. We saw something coming up. But what happened? Okay, let's try again. Sine squared x. I think I lost my way somehow. We FOIL this thing, so we get 2 cos squared x over 1 times sine x over cos x. This is where the problem came, because there's a sine x here. Now I'm trying to think. Why don't I use the sine one here? Okay, let's leave it at that. It feels like kuyafiwa ngoku. It feels like kuyafiwa mos. All of this, guys, so I'm gonna do a complex thing now. Once we FOIL it out, we divide by sine squared x. Then the next one is gonna be minus sine x over cos x, all of this divided by sine squared x. Yeah. Ne? I feel like something is not adding up though. Something is not adding up. This takes that. Right. Okay, let's simplify this meticulously now. This is 2 cos x sine x all over sine squared x minus this is going to be sine x over cos x times sine squared x. Remember, this one is going to be right on the denominator, because that's a fraction on its own. the top, right? So I think someone may have made a mistake. I think there's a mistake in this question, in the solutions, of course, by the memorandum, because for me, I get the feeling that, but it doesn't work the way I'm thinking. I'm not thinking right. Okay, guys, this one is humbling me now. Iyadihambulisha. So we have 2 cos x over sine x. So there it is. Cos over sine is coming up. But now the problem here is this dude. For me, it looks and feels like this square was supposed to be there. The sine was supposed to be here. That's what I feel. Because this way, I'm not getting anywhere. Of course, this is solving this properly. We end up with 1 over cos x sine x. But in any case, we see that there's a 2 that we have here. And we just want to get rid of that 2. How do we do this? Well, we can multiply by half. But this one is going to be dangerous in that, as much as it will work for us here, but it's going to create a whole new different situation. Can get rid of that too, but it won't get rid of this one. So, it's not gonna work. Okay, guys, so our challenge is that we have 2 and we have something strange here. Ne? Yeah. Okay. It looks like I'm not gonna get to these questions. Diniwe mnango. Ndidiniwe ndicela nizenze zibe homework, guys, is ngeke. Nansi question ifuna niqhela kakubi phaya. Alapha. Cela nizenze homework. Thatha snapshot. Qibile mosne. Thatha nalena, pause it. It's done. So, nansi question apha isibambile ngoku, isibambele eduze. Angisazi ukuthi phela uma sekunje sekumele senze njani. Jonga-ke xa kufela right hand side, sometimes you may, here's another thing I'm forgetting. You know what? It feels like I can't proceed here. And when I cannot proceed, what can I do? I can actually try to take the right hand side as well and drop it down to something like this. Maybe it's gonna happen, maybe it's not gonna happen. I don't know. But I feel I have done some crime. Because there's a 2 I don't know how to get rid of. I don't know how to get rid of this 2. And there's a 1 here, which I also don't know how to get rid of. Oh yeah, 1 is an identity. Why do I forget this? Lord of Lords. 1 is an identity. So this is 2 cos x over sine x minus, this is going to be sine squared x plus cos squared x all over 2 cos x sine x. All right, so let's see if this works out in any way. 2 cos x over sine x minus, sometimes the thinking guys will always be wrong, so now we divide each term on the numerator by the denominator. Sine squared x over cos x sine x plus cos squared x over cos x sine x. Yeah, this question was hot. Now I can see where I am going. Of course, if you forget the three-step approach, guys, you would go wrong, because we should have thought about it. It's an identity, this guy. Yes. Okay, so we've got 2 cos x over sine x. Now we know that the magics will happen. This one takes that, great, and then this cos takes the square, and then we FOIL the negative, so we get minus sine x over cos x minus cos x over sine x, and of course these are like terms. So 2 of these minus 1 of that is just going to be just 1 of that, minus, this is the tan of x using identities. This is equal to the right hand side. Okay. Yikes, that was a bit hotish. It's easy to miss it, of course, if you forget the three-step approach like I did. As you can see, guys, to take chances, okay, can be quite not a problem after all. So we used identities here, we're winning. The 10 identity, we're winning. We FOIL stuff out and divide, all of this gymnastics. They look a bit too complex, but I think when we start using the identity here, that's the third mark, 1, 2, 3. And here using the 10, 4. Okay, right. Yeah, guys, there's a lot of things here. So there are lots of areas where marks can be given. But I think undoing this here was a key step. Maybe this is where the 5 marks are. The rest is, as you see it, guys, complex. All right, so let's take those 2. I thought we were not going to finish this one on time. Let's quickly rush through these ones so that we can be complete. Now we're taking another question 10. So these questions we just did. Anyway, for those who are doing the upgrading exams, yeah, these are the type of questions you want to practice. Otherwise, these are likely to haunt you in this exam. So we've got 4 sine A cos A times cos 2A times sine 15 degrees, all of that divided by sine 2A into 10 225 minus 2 sine squared a. This is to be equal to square root 6 minus square root 2 divided by 2. Okay, nice and easy. Left hand side. Okay guys, I'm feeling this. I'm hungry actually. Actually, you know, you can see even with me when you are tired and hungry and not focusing, mistakes or even a failure to realize what is so obvious is a common issue. So be very careful. When you feel tired, don't do complex questions or difficult questions or higher grade questions. The moment you feel a bit overwhelmed after a difficult question, perhaps take the simpler questions. Go and relax on the simpler questions. That's how you relax while working. Okay? Take the simpler ones after a difficult one. Don't do a difficult one after a difficult one because you will exhaust your brain's thinking. And as you can see, just missing one as an identity is a nightmare. You end up not knowing how to solve. So again, skip the question if you feel you can't get around it also. Don't force it. Look at it one more time. If you can't get it, skip it so that you don't lose time. You will come back. When you do, you'll probably have your thoughts back. But what is important is always keep simple questions as a form of relaxation. I know a lot of people tell you, start with the easy questions and finish. And then you end up working hard because even easy questions, when they come one after another, you end up getting used to the easy questions. And guess what happens? You will feel tired. Then it means the difficult questions are going to become impossible for you. So if you start with the difficult questions, then once you get a bit percussed by those, you go back to the simpler questions. Those ones form a bit of a relief and it feels like a bit of rest. You get it? Then you breathe a bit because those ones are easy to chew upon. They relax your brain. Sometimes they just refresh it a bit. Then you go to another tough one. Chow it and then you go. Just keep the simpler ones as a way of relaxing. I promise you guys, if you make an exam enjoyable instead of this daunting thing that you make it, don't be stressed over marks. If you're not going to get a distinction, you're not going to get it, even if you stress over it. If you're not going to pass, you're just not going to pass, even if you stress about it. But the moment you relax and take your time and strategize on how to attend to that paper, I promise you, you may end up getting a distinction that you will surprise yourself with, And you will also surprise some people who thought you were going to fail by passing very well. Anyway, guys, let's not talk because I know I'm going to talk until Jesus comes. But when I talk, I'm always buying time because I'm usually very, very tired by the time we do our things. Anyway, guys, so we can see that 4 sine A cos A looks like a double angle identity of sine, but we need to showcase it. This is 2 times 2 sine A cos A times, let's just leave this one for now because we don't know how we want to deal with this. So we're going to leave it for later. So let's not rush to A. Sometimes you just don't want to make it too easy, too difficult for you. Because how we change this, sometimes we need to look in the denominator once we simplify. So this is sine 15 degrees, okay? All divided by sine 2A. I think I'm creating 1 in the numerator and it's all a product. We keep it. Sine 2A into 10, 22, whatever. We can create a big bracket here. This is 10 of 180 degrees plus 45 degrees minus 2 sine squared A. This one we can leave alone. So this is already giving us the idea that this cos 2a must perhaps be done in terms of this, but we will take our time to do it. We will take our time to do it. Sometimes, relaxing on the job while doing the job is good. So we get 2. Now this is an identity. It's expanded, we contract it. So this is going to be sine 2a times cos 2a times sine 15 degrees all over 2. Sine 2a, we break the big bracket. This is as good as 10 45 degrees minus 2 sine squared a. Okay, this one is the same as the one. Since that is a product, with the product, these ones can divide to 1. And then we are doing grades. So we see that we have now 2 times, okay, since we got what we got here, we will see that this, we can actually start using this one, minus 2 sine squared a times sine 15 degrees. Remember the acute angle, you deal with it later. Now we know what's left. 10 45 is 1 minus 2 sine squared a. Yeah, when that takes care of that. And then what do we end up with? It's 2 times sine 15 degrees is 45 degrees minus 30 degrees using special angles over 1. In fact, we leave it like that. This is the same as 2 into now we expand this. It's going to be sine of the first angle, cos of the second angle. The sine remains, cos of the first angle, sine of the second angle, 2 into sine 45 is 1 over square root 2 times cos 30 is root 3 over 2 minus cos 45 is 1 over square root 2 times a half. Okay, yeah, this one is also a naughty one. So well, let's just simplify before we do things. So we will have here root 3 over 2 root 2 minus 1 over 2 root 2. Now guys, bottomers, we deal with brackets first. Well, one can easily FOIL out or just deal with it, okay? Easy. But in fact, I think to FOIL out is much better than to go the common denominator route. Let's just FOIL out. So when we FOIL this out, we know that this 2 will take that 2 and that 2 when we FOIL out into the other one. So what do we end up with? Root 3 over root 2 minus 1 over root 2. Okay, we take the common denominator. I guess we just couldn't escape it. Okay, so we end up with root 3 minus 1. Okay, so we saw that our answer doesn't have what we have, so we're rationalized. So we will always do it. So this means we will have root 2 times root 3 minus root 2 divided by 2. Okay. Now root 2 times root 3 set rules will just have 2 times 3. Okay, minus root 2 over 2. I'm just showing you all the steps, guys, but this could easily be seen from the above already. Yeah, this one was a situation. Okay, guys, we've done it. So since this one is too easy, I doubt we would have an easy way returning it back like that. Yeah, it would be a nightmare even. So I think we don't need to say this and that. Okay, as you can see, guys, just arithmetic gymnastics here. Let's have a look. What do we say? Well, we are going to essentially deal with this. Breaking this up is just setting it up, not a big deal. Nothing changed here. And then when we used an identity, we get a mark. And this reduction here is a mark, 2 marks. And then when we use this identity here, it's another mark, 3rd mark. The value of a special angle, where is it? It's 1 here. So that's again 1, 2, 3, 4. And then 5. Perhaps that one is not so strong, but the expansion, identities, 5. And then using special angle, 6. Yo, hey, 1, 2, 3, 4, 5, 6. But there should be more, but of course rationalizing is just as good as multiplying by 1, which is a logical step. I don't know, but I feel this one should get a mark as well. Using set rules is also very good, so I don't know how this question was marked, but I feel like it's not. It's more than 6 marks, guys. It can't be less than 6 marks. This is already too much punishment. Okay, all right, okay. So let's take the last one, guys, as we promised, and leave you in peace. Okay, it looks like we made it into the 2 hours. Okay, let's have a look here. We've got another question 10. My foot is cold. Yo. I ended up solving because, yeah. I'm feeling like ngikhathele, so I might as well just finish here so that I can rest. So sine to the exponent 4x. Please don't say sine to the power 4. Hey, ningazondibizela into endingazazi mna. Ayikho into enjalo. Cos squared x all over. Of course, only in my class you're not supposed to say that. In your classes with your teachers, hey, say what they say, guys. Otherwise, they will victimize you. Because they will think you are thinking too highly of yourself. It says now, for which values of x is this situation equal to that not true? Which values of x? I was supposed to prove the identity, man. Let's leave this one for later. Okay, I like this question. It's a higher grade question, actually. So when we say not true, what do we mean in maths? Undefined. That's another way of saying it. Okay, so now I gave you the clue, so maybe you want to solve that question. Because how maths is written sometimes, it's a language, eh? It's a language. Be careful to not see it as such. First of all, let's just do the identity. So this was 10.3.1. The left-hand side is more complex, so we want to handle it. So of course I've got the luxury, you don't. Yours is to copy this again as meticulously as possible. So we're going to deal with our problems just right. So how do we do it? We take out the highest common factor. We start off by factorization. So sine squared x is a common factor here. So we end up with sine squared x plus cos squared x, all divided by 1 plus cos x. Okay, nice and easy. So this is sine squared x into 1 using identities over 1 plus cos x. Okay, so this is nothing but sine squared x over 1 plus cos x. So that's a square, so which comes out as 1 minus cos squared x using identities again. So over 1 plus cos x, we know that the numerator is a difference of 2 squares. Okay, that was a bit, looked too simple, but is a bit. And then of course this takes care of that in terms of just dividing to 1. And this is 1 minus cos x indeed, which is equal to the right hand side. All right, okay, all right. So identity has been proven. As you can see, some questions are easy, some questions are not. So you just get used to the different flavors. And on top of that, try to use everything you have been taught and everything you have realized by yourself or noticed by yourself, or anything you can bump into. So of course, 3-step approach, factorization works. Using identities, good. Using identities again, good. Factorization, good. And it leads to the answer, so the 4 marks is proper. Now we need to prove for which values of x is this situation not true. So remember, this question is more like doing general solutions, because here we were not given a domain to look at. So if we're not given a domain and we're solving for x, that's nothing but a general solution. So remember this. Okay, essentially, of course, it may not necessarily be that. The solutions might be even easier than, what we see. So when is this going to be not true? Of course, it's when the denominator is 0. So it only happens that this is not true when the denominator of the left-hand side is 0, because here there's no denominator. The denominator is 1, so it's already not 0. Okay. All right, okay. So let's have a look at this 10.3.2. This happens when 1 plus cos x is equal to 0, which implies that cos x is equal to minus 1. This implies that x is equal to plus or minus arc cos of minus 1 plus k times 360 degrees, where k is an element of integers. Of course, guys, I didn't want to do general solutions, but this question is quite popular lately. So a lot of you guys seem to really struggle to think about this. This is just pure algebra, rational numbers. Because whenever we talk of undefined situations, we're literally assuming some form of rationality. This is saying rational equations, the denominator when it's 0. Wow, it does not exist. Okay, this implies that x is equal to plus or minus arc cos of minus 1. That's like 180 degrees. Yay. So this is plus or minus 180 degrees plus k times 360 degrees, where k is an element of these ones, the z's, which is my name. All right. This also implies that x is equal to 180 degrees plus k times 360 degrees, or x is equal to minus 180 degrees plus k times 360. Okay, as you can see, it's not a lot of marks, of course, but I just like to solve. Now, obviously, guys, obvious. So this is not true when what? When cos is minus 1. And when is cos minus 1? At 180 and at minus 180. So we don't need all these other solutions because they are just too many. Sometimes I feel like this is good enough. You leave it at this, because if you just come up with just 2 solutions, what about the repeats? Because there was no domain here. And it just said values of x, no restrictions. So general solutions, in my opinion, is the way to go. But somebody may say, therefore, x is equal to plus or minus 180 degrees. This is acceptable for now, but remember, this is not true. Because when we say values and we did not limit, remember, these things repeat. So general solutions here are the best way to go. For me, this is the best answer. Although some people may argue, because memorandums, sometimes they just go on and talk serious treason, or they give treasonous statements. Because, yeah, to say this is the only answer is a treasonous statement. But one can argue that, okay, in our Cartesian plane, guys, we only have 4 quadrants from 0 up until 360 degrees. So, and of course, negative angles. But can you see minus 180 is like the negative angles and stuff. So, I don't know. So this is minus 180 degrees and 180 degrees here. This is 270 degrees and minus 90 degrees. I mean, we can argue about it and say, okay, we often look at the Cartesian plane first anti-clockwise for 1 revolution, and we look at it 1 revolution anti-clockwise, where we will end up with minus 360 degrees here. So essentially, we can argue and say, okay, plus or minus 180, it doesn't matter what it stands for. This could be the reference angle. Okay, it's fine. We can accept it, but it's treasonous, because there's other angles like 400 and some change that have something to do with this, because those are equivalents, and nobody gave us a restriction here as to in which domain. So technically, to present this as the answer is not quite correct. Okay? But the correct one is the general solution, because it captures all those solutions that will make our identity untrue. But you can make a bit of a case here by arguing that our Cartesian plane cast diagram, whatever you call it, is somewhat anchoring on these 2 values only, because everything else is just a repeat of these or multiples of these values. So in a way, okay, all right, okay. Yeah, folks, this is it. Let's cut it here, guys. Otherwise, I will spoon feed you until you regurgitate and you will think you know when you actually don't. So I don't want that. So for me, folks, these are the solutions. Where the marks come from is actually equating this to 0. Very important, because it defines the not true part, and then both of these solutions have to be correct. Whether you mark it here or you mark it there, it doesn't matter. But I would rather this is the solution because it is restrictless. Huh? Is there such a thing? Restrictless. Aye. English wrong leyo. Chini nabafundi. Senilambela ondlela banzazenibhude. It's non-restricted or unrestricted. Alright, okay, alright. Otherwise, guys, I hope you enjoyed the video. A nice 2 hours of some serious work, I suppose. And you can see I also choke along the way because remember, I don't do videos where I pre-solved a problem. Why I do this is because I want to show the student that there's no one who's perfect at this, but we just find our way by following rules, tricks, techniques, logic, our experiences, sometimes just, luck coming in as well to save us. Of course, when something doesn't work the first time, you try it again, perhaps slightly changing things because you can't try it the same way and you expect a different answer, right? That's a definition of madness. But what is important here, when you try it again, of course, before you try it again, first check what you've done and see if is there anything you can do different in it. And if so, please, when you try it again, do that which you saw you can do different so that you don't end up in the same place, right? So that's just the key here, guys. So practice. Please don't panic. Some questions are just not going to be possible for you to solve within the 3 hours you are allocated in the exam. So just sometimes accept defeat in certain questions, okay? So that you can maximize on others. Of course, if you still have time, you can come back and try again. Who knows? Your luck might just turn up at that time. Otherwise, I'll see you guys next time. Goodbye.